Welcome back. Today we are talking about lesson 11.5, which is about counting principles and permutations. So let's jump in here. When we are trying to count the ways an event can happen, we often use some tree diagrams to kind of help us figure that out. So in a tree diagram, we have an experiment that can be broken down into two different stages. And so we can then draw those stages out in a tree diagram. So let's look at an example here. So in the tree diagram we're going to look at here, we are at a sub shop and you have to decide between Italian or wheat bread, and then you have to decide whether you want ham, turkey, or roast beef on your sandwich. So we're trying to figure out how many different ways we can choose a sub or make a sub with one type of bread and one type of meat on it. So when we do that, we have this tree diagram. We put our first choice in the left-hand side of it. So our first choice is to select our bread. So we can choose Italian bread or we can choose wheat bread. So we break those up. And from each of those, once we've chosen our bread, we then have to choose the type of meat. So the first choice is ham, or we can choose turkey, or we can choose roast beef. So there's three different types of sandwiches we can make on Italian bread. Then we have those same things for wheat bread. So for wheat, we can choose ham, or we can choose turkey, or we can choose the roast beef. So that's what our tree diagram would look like. So we obviously are repeating the meat because we can have it with the Italian or we can have it with the wheat. So we repeat it down there. So when we count those, there are 6 different ways that we can choose a sub. So one way to start counting different options with things that can be broken down into different stages is to draw this tree diagram and then count the possible outcomes at the end. If we want to avoid counting and drawing all of that out, we can instead use, or we can do some other methods that we've come up with in order to avoid having to do that. So we have what is called the addition counting principle. So this is a way to do the same thing or similar thing to what we were just doing, but without having to list everything out. So if there are m ways of doing one thing, so in the last example, there were 2 ways of choosing bread, but if we were picking a color of a car, maybe there's 5 different colors. So m is just the number of ways of doing the first thing that we have to choose. And then we'd have n ways of choosing the second thing or doing the second step in the process or the second stage. Then together there are m plus n, so that's where the addition counting principle comes in, ways of doing one thing or the other thing. So we could choose 2 breads or 3 meats. Together there would be 5, if in that example up above. So in this case, we are trying to do one or the other. So in example 2 here, it says you've accumulated 20,000 points on your credit card. You can use those points at one of 10 hotels, or you can choose one of 5 airlines to spend those points on. So you can do one or the other. You can't get a hotel and a flight. You have to do one or the other. So when it asks how many ways can you redeem your points, there's 10 ways to choose a hotel or 5 ways to choose an airline. So that means that there are 15 ways we can use the points. Because we're spending them in one place or the other place. Now, if we go back to that sandwich example from above, if we want to choose a sandwich and a type of meat to put on the sandwich, then we're going to use a different counting principle. So if that's the case, we're going to use the multiplication counting principle. So same idea, if a task can be broken down into 2 different stages, and there are m ways of doing the first thing and n ways of doing the second thing, then there are m times n ways of doing one thing and the other. So if we go back to the example from the sandwiches, if we have 2 types of bread and we want to choose a type of meat, there are 3 different meats we can choose from. That would give me a total of 6 ways of making different subs, which is the same thing we got when we drew out the tree diagram and counted them that way. This way we just don't have to draw it all the way out. Okay, so then for B here, it's asking us to do the same thing from example 1, but now we're going to have a third choice. So now we're going to choose a type of bread, type of meat, and we're going to choose a type of cheese. So again, there were 2 types of breads, 3 types of meats, and now we're adding in the addition of 2 different cheeses that we can choose from. So what that does now is it changes it from 6 different subs to 12 different subs that we can make. 1 with each type of bread, meat, cheese. And so that is the multiplication counting principle. All right, so as we get into more and more complicated problems with these, we sometimes need to be able to multiply a lot of things together. And when we do that, we can sometimes use what's called a factorial. So a factorial of a positive integer, so any positive integer value, we can use a factorial. So any positive integer, we'll call it n, can be written as n exclamation point, which is not an excited n, it's called n factorial. So in math, exclamation point is called a factorial. When we have that written out, it is the product, so multiplying all the integers less than or equal to that value together. So if we have n factorial, it's n times the number before it, times the number before it, times the number before it, all the way until we get down to 1. So if we have 0 factorial, that's a special case. When we have 0 factorial, it's just equal to 1. Since there are no positive integer values less than that, we just say 0 factorial is equal to 1. Okay, so let's practice a little bit with factorials before we use them for some counting. So in this case, it's asking us to calculate 8 factorial. Again, that exclamation point in math, we read it as factorial. So that means that we are multiplying 8 by all the numbers lower than it until we get down to 1. So we're doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So using a calculator, we can multiply those together. Some calculators even have a factorial button if you want to find that. But otherwise, you can just type it all the way out. When we multiply all of those together, we get 40,320. All right, let's look at this next one. So this next one is 2 factorial, 5 factorial. So that means that we are multiplying 2 factorial, which would be 2 times 1, 2 times all the numbers below it down to 1, times 5 factorial. So 5 times 4 times 3 times 2 times 1. When we multiply those together, we get a total of 240. For our third one, now we're dividing factorial. So we have to be really careful here and really understand what the factorial means. In this situation, we are in the numerator multiplying 7 by all the numbers below it down to 1. And then the denominator, we're multiplying 4 times all the numbers below it. When we do that, we start to see that there are numbers that are the same in the numerator and denominator, which means they cancel out to 1. So when we divide a number by itself, it cancels out to 1. So those would eliminate each other, and all we're left with then is 7 times 6 times 5 in our calculator would be 210. So we can do factorials, we can multiply factorials together, we can divide factorials from each other. So we're now going to use those to start to figure out some different counting principles as we go. Okay, so the first thing that we're going to look at here is permutations. So permutations are where we have a set of objects, whatever they might be, where we want to arrange them in a way that order matters. So the big thing we have to remember is that order matters in permutations. So the most common thing I think about with this is like if we're running a race, it matters which order you finish the race in. The winner is the first one to finish. The second place is the second person across. So the order in which it happens. If I'm picking random numbers out of a jar, it doesn't matter what order I pick them in, so order wouldn't matter for that. But if we're trying to keep track of the position, then order matters, and that would be a permutation. In the next lesson we do, we're going to talk about what happens when order doesn't matter. So for today, order matters. That's what makes it a permutation. Okay, so when we have permutations, we can use that multiplication principle we just talked about with factorials in order to figure out different amounts of things that can happen. So this first example says there are 10 soccer teams in the competition. In how many ways can the teams finish the competition? So if we have 10 soccer teams, like I was talking about with the race kind of, there is one team that can finish in first place. So before the competition starts, or the tournament starts, or whatever it is, there are 10 possibilities for teams that can finish in first place. Before we play any games, anybody could finish in first place. Once the first place team is locked in, now there are 9 teams left that could finish in second place. Continuing that on, once the first and second team places are determined, now there's 8 teams left that could finish third. So on and so forth, down to the last place spot. After all the other ones have been determined, there's one team left that'll have to finish in last place. When we do that, we can see that, oh, this is a factorial. There are 10 positions that the teams can finish in. When you multiply them all together, in this case, there are 3,628,800 ways those teams could finish before anything happens. So a shortcut, rather than having to write it all out, is to say, well, that's just 10 spots that the team. So to take that a little bit further, in question B, it says the first place team receives a trophy and the second place team receives medals. In how many ways can those awards be given? So now we only have 2 spots to fill. Sorry. The 10 teams can only fit into 2 spots. After that, you don't get anything. So in the first place to receive the trophy, there's 10 possible teams that could receive that trophy in the beginning. Once the teams receive the trophies, now there's only 9 teams left that could receive the medals. After that, we don't care because they're not getting anything after that. So in this case, there's 90 ways, if we multiply those together, for teams to receive a trophy or a medal. 90 different orders. So that's like first place, second place, right? So anytime we have that, we're going to keep track of how many can go in each position. All right, we're going to take that one step further here, and we're going to talk about permutations of n objects taken r at a time. So this is what happens when we say, okay, you have this many teams to pick from, or this many objects to pick from, and we're only going to select a certain number of them. So we're picking a certain number out of a total. So when we have a permutation like that, it's written in this format here, NPR, where the P is a capital, N and R are little subscripts on each side of it. So N is your total number of objects, and R is how many you're picking, or how many you're selecting. So when we are taking a certain number out of a total, the number of ways we can pick that many objects is n factorial over n minus r factorial. So let's look at an example of that. So in example 6, part A, it says write a permutation for example 5b and solve using the formula. So in 5b, if you remember, that was the first place gets a trophy, second place gets a medal. So in that case, we have a permutation where we had 10 teams and we were selecting 2 total. First place gets a trophy, second place gets a medal. That's all we care about. Everybody else didn't get anything. So if we use the formula for that, the total is 10. So we do 10 factorial over 10 minus 2 factorial. So if we simplify that, that's 10 factorial over 8 factorial. And hopefully we remember from when we were practicing with that, that means we have 10 times all the numbers below it. Divided by 8 times all the numbers below it. And if you remember from when we were dividing before, anytime we have a number divided by itself, that means we can cancel it out to 1. So the 1s, the 2s, the 3s, all the way up to 8 reduces to 1. So now we just have 10 times 9 times 1, essentially, which means we have 90 ways. So you can see how that formula gets us the same result as before. All right, so then we have part B here, which says evaluate if we have 6 things that we're picking from and we choose all 6 of them, first place, second place, third place, all the way through 6th place, basically. So in this case, we have 6 factorial over 6 minus 6 factorial because we're selecting everyone. So in this case, everybody gets a prize of some sort or whatever the situation might be. So in that case, we have 6 factorial over 0 factorial. So remember from our rules that 0 factorial is a special case and it just equals 1. So in that case, we have 6 factorial over 1, which is really just 6 factorial. When we multiply that out, we are left with 720 ways that they could finish all the way through all 6 of them. All right, so then our last thing here, what happens when objects are alike, where some of our choices are the same? So if I'm picking something and some of the options are the same, it doesn't matter which of the same things I pick, so it changes it a little bit. So if we're given a set of n objects, so still the same number of total, in which P are alike and Q are alike, so maybe we have 3 of one type of thing and 4 of another type of things, that would be P and Q, then the number of permutations of those objects uses this formula here. So we do the permutations and then we divide out kind of the repeats, if you will. So number 7 says find the number of permutations of the letters of the word mathlete. So in mathlete, we can see some repeats going on. So we should hopefully see that there is 2 T's and 2 E's. So those are some repeats that are going on there. So if we look at our formula, the top or the numerator of the fraction is n number of items chose n ways. So when we're doing that, we're counting the unique things that are happening. In the word mathlete, there are a total of 8 letters that we're going to choose from. So 8, choose 8. And remember from that example before, we should hopefully remember that when we have a permutation where we're choosing all of them, that really is just 8 factorial. And then we're going to divide out the repeats. So what I know is that T repeats twice, so that's 2 factorial, and E repeats twice. So I'm going to divide out 2 factorial twice. If there were more letters that repeat, we could keep going. You can do it as many times as you need to. So when we do that, that would be 2 times 1 times 2 times 1. And on the top, we would have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, when we multiply all that together, we get a 4. So I'm always a fan of canceling out anything I can. So we can do that. You can also just use your calculator. Either way you do it, when you multiply those all together, you end up with a total of 10,080 ways we could write the word mathlete if order matters. But it doesn't necessarily have to spell a word. So those are all your counting principles and permutations. We'll see you next time.